Okay, so for the following circuit, we have to find IT. So let's draw. So pretty much when t is less than 0, this switch over here, it should be closed. So let's draw the circuit for when t is less than 0. So we have I moving here. We have 4 ohms. We have 10 volts. 3 ohms. Oh yeah, and then there's an inductor here. Sorry. So 6 ohms. Then we have an inductor and a capacitor. So inductor, capacitor. So we're assuming that the circuit looked like this for a long time, so that means this becomes an open wire or open circuit here, and this short circuits and becomes a closed wire. And we're going to find the current in this state and the voltage that would have been at the capacitor at this state. So I will be 10 over 6 plus 4, which gives you 1 amp, and V will be 10 minus 4 times 1 amp, which should give you 6 volts. Okay, so this is going to be your I at 0, and this is going to be your V at 0. Okay, and because obviously when t is equal to 0, these values cannot change instantaneously. So yeah, so the second this switch is opened, the voltage here and the current here will be these following values when t is equal to 0. Okay, so now we're gonna open this switch and draw the circuit for that. So we see that this region, it becomes disconnected from this region, so we're just gonna ignore this and we're just gonna focus on this. So the circuit will look something like this for when t is greater than or equal to 0. So we have the following. This is 6 ohms, 0.5 henries, 0.02 farads, and 3 ohms. So what we're going to do is we're going to do, oh yeah, then there's current here and voltage here. So what we're going to actually do is do a mesh. Okay, let's call this I. It's in the same direction as this I. So it's going to be 3I plus 6I. So 3I, 6I. I'm just doing the resistors first. Plus inductor, the current passing through the the voltage at the inductor, and then the voltage at the capacitor, which is going to be 1 over C times the integral of V dt plus the initial current at this capacitor. Okay, so I'm gonna try and get rid of this integral. So what I'm gonna do is differentiate all of this. So first, let me add these up. So it'll be 9 di over dt plus L d squared I over dt squared plus 1 over C times V. This is a constant, so this just cancels out. And all of this is equal to 0. Now I'm going to rearrange this. I'm going to divide everything by L to get this part alone. Okay. Wait, sorry, not 9C, sorry, LC. There you go. Alright, and notice this looks like the quadratic formula, right? Oh wait, sorry, I made a mistake. This should have been an I, and this should have been a V. Sorry, so the initial voltage at this region. So yeah, my bad. That means this is supposed to be an I, and this is supposed to be an I. There you go. Okay, now that's better. So notice this. Uh, if we set di over dt to be m, then it's going to be, actually no, let's do s. There'll be s squared plus 9 over L s plus 1 over LC. And that we can use the quadratic formula to solve. So it'll be 9 minus 9 over L plus minus 9 over L squared minus 4a, which is 1, times c, which is 1 over LC, all over 2a. Alright, now we can break this up into like this. So this region, it just becomes minus 9 over 2L plus minus. If we were to instead do the square root of 4, which is still 2, we can put this inside this. So it'll be the following: 9 over L squared minus 4, 1 over LC, all over 4. Okay? This is the same thing as this. Like that. Okay? So we could just, have a square root represent the whole thing. Now we can break this up. And this cancels out. And if we take the square root of this, we can put that into here. So we can do the following. There we go. And now this one, I'm going to square root this whole thing and then square it. Okay, that pretty much didn't change really anything. So this is the same thing as the following. And now this and this is going to be your alpha, which is your damping factor. And this is your omega O, which is your undamped natural frequency. So we write this in the following format. Okay, so alpha is going to be equal to 9 over 2L, and recall 9 was your resistance, so it's technically the resistance over 2L, and omega O, that's pretty much equal to 1 over the square root of your inductor times capacitance. Okay, now the next part is figuring out, so let's actually solve for the following. So R is 9 all over 2L, so 2 times 0.5, that should give you 9, and this is in radians per second. And omega, it's 1 over the square root of 0.5 times 0.02, and that's 10 radians per second. Now we're gonna check the following. So if alpha is greater than omega O, then it means we have an overdamping circuit. And to find the current passing through the inductor, which will be this current, the formula will be pretty much A1 e to the power of S1t plus A2 times e to the power of S2t. S1 and S2 being, the two roots that you get from here, from your quadratic formula. Now, if they're both equal to each other, that's critically damping. And the formula for this one will be A1 plus A2t times e to the power of negative alpha t. And now if omega is greater than alpha, then it's an underdamped circuit. And underdamped. And this one's the longest formula. It's going to be IT equals e to the power of minus alpha t times A1 sine WD. This W is supposed to be your your damping frequency, which will be so pretty much if this is greater than this, you're gonna get a negative square root, and so whatever is being times by your imaginary number, that's gonna be your WD. Then times it by t plus a2 cos WD times by t. Okay. Well, actually, usually they write it like this way, but both should be the same. But usually they have the sign at the right side. All right. So what do we see? We see in our case, our uh, our alpha is less than our omega. So that means we're going to be using this formula to solve for this. So let's first find what our WD will be. So we know S will be equal to minus 9 plus minus the square root of 9 squared minus 10 squared. And this will be equal to minus 9 plus minus the square root of 19j. Okay? So hold on, let me just double check that. Yep, okay, looks good. So that means our WD will be the square root of 19. So what we're going to do now is write the following. IT is equal to E. Recall our our alpha is 9. So it's going to be minus 9t times A1 times cos the square root of 19t plus A2 sine the square root of 19t. Now, we have to solve for A1 and A2. So to solve for A1, it's going to, to solve for A1, it's going to be pretty easy. Recall the following. When I is 0, when t is 0, our I is at 1. So we'll write the following. Okay, so this is fully gone, and this is just 1. So our A1 is equal to 1. Alright, now to find our A2, this is the tricky part. So what we're going to do is first we're going to differentiate all of this. So it'll be di of t over dt equals, so the derivative, so you have to use chain rule. So it'll be minus 9 e to the power of minus 9t. A1, recall A1 is now 1, so we'll just write cos square root of 19t plus A2 sine square root of 19t. Okay, plus e to the power of 9t. This turns into minus square root of 19 sine square root of 19t plus A2 square root of 19 cos square root of 19t. Okay, so now we have to find our di over dt, and we can use the following here to solve for it. So we know what our I, so if we look at it from when t is equal to 0, we know our I is going to be 1 amp, and we also know that this whole value is the voltage at our capacitor. Okay, and we pretty much know that that's going to be 6, right? So we just have to now solve for di over dt. So we're going to take this. So we have 9 times 1 plus L di at 0 over dt plus 6. Okay? And if you confuse what I'm doing, this is we're pretty much using these values to solve for this. And L is 0.5. So after rearranging everything, we should get di at 0 over dt to be minus 6. So here we're going to put minus 6, and we're going to set t to be 0. So this is 0. So this one will just be 1 plus 0 plus 1 times 0 plus a2 square root of 19. Okay? So now let's see. So let's make this one look more nicer. Okay, so this one will be 9 minus 6 all over square root of 19, which is 3 over the square root of 19, which is 0.68824. I'll say I'm just going to work with this value. So, and this is what a2 is equal to. Now we can finally solve for our final answer. I of t will be equal to e to the power of 9t times cos, wait, sorry, times cos square root of 19t plus 3 over square root of 19 times sine square root of 19t amps. And this represents the current that's passing through the inductor, which is this one.